Welcome to our channel on occupational health and safety. Today we are going to train you on machine safeguarding. The requirements. Every company must assess the risks to workers associated with moving and energized machinery and mitigate identified risks through the provision of all appropriate machine and access guarding. One or more methods of machine guarding must be used to protect operators and other employees from hazards, including those created by point of operation, in running nip points, rotating parts, flying chips and sparks. This provides the minimum requirements for the guarding of machinery and equipment. Examples of guarding methods are barrier guards, two-hand tripping devices, electronic safety devices, etc. Different definitions. A guard is a physical barrier that prevents contact between any part of an operator's body with a machine hazard. Guards include physical guards, such as casings, covers, screens, doors or enclosures. Guard may either be fixed or movable and located on or near the machine equipment. Fixed guard is a guard that is kept in place permanently by welding or by fasteners that can only be released by the use of a tool, and when in position it should not be capable of being displaced casually. Where fixed guards need to be removed periodically for maintenance or clearing a jam-up, they could be a hinged door or a slot-in panel secured by a bolt or other suitable device. Interlocked guard is a physical or electrical control attached to the equipment, or to ancillary equipment that is electrically interlocked to the operating circuitry of the equipment so that the equipment cannot be started normally unless the guard is engaged. The interlocking system may be either mechanical, electrical, hydraulic, pneumatic, or any combination of these. Machine hazard. Typical hazards related to moving and energized equipment include, but are not limited to the following: crushing, flying objects, noise and vibration, shearing, electrical shock, entanglement, drawing in or trapping, impact, ejection, cutting or severing, stabbing or puncture, high pressure fluid, friction or abrasion. Warning on entanglement, warning on shear hazards, warning on hearing protection, warning on cutting, and warning on eventual puncture and stabbing. Safety device. A non-physical measure for providing the desired level of protection, such as interlocks, pressure-sensitive trips, electrosensitive protective devices, photoelectric curtains, etc. Safeguard. A general term that refers to the means provided to protect against access to dangerous parts of a machine. It can be either a guard or a safety device or a combination of both. A pinch point is any point at which it is possible for a part of the body to be caught between the moving parts of a machine or equipment, or between moving and stationary parts of a machine or equipment, or between the material upon which the machine is working and a moving part or parts of a machine or equipment. A safety device is a non-physical measure for providing the desired level of protection, such as interlocks, pressure-sensitive trips, electrosensitive protective devices, photoelectric curtains, etc. Safeguard. A general term that refers to the means provided to protect against access to dangerous parts of a machine. It can be either a guard or a safety device or a combination of both. A safety system is the integrated total system, including the pertinent elements of the machine, the controls, the safeguarding and any required supplemental safeguarding, and their interfaces with the operator, designed, constructed and arranged to operate together as a unit, such that a single failure or single operating error will not cause injury to personnel due to point of operation hazards. Stop control or e-stop. An operator control designed to immediately deactivate and stop a machine or ancillary equipment. Requirements for machine safeguards. Machine safeguards must meet these minimum general requirements. Prevent contact. The safeguard must prevent hands, arms, or any other part of a worker's body from contacting dangerous moving parts. Be secure. Workers should not be able to easily remove or tamper with the safeguard. Guards and safety devices should be made of durable materials that will withstand normal use. They must be firmly secured to the machine where possible or secured elsewhere if attachment to the machine is not possible. Protect from falling objects. The safeguard should ensure that no objects can fall into moving parts. Create no new hazards. A safeguard defeats its own purpose if it creates a hazard such as a shear point, a jagged edge or an unfinished surface. Edges of safeguards should be rolled or bolted so that they eliminate sharp edges. Create no interference. Any safeguard that impedes a worker from performing a job quickly and comfortably might be bypassed or disregarded. Proper safeguarding can enhance efficiency because it relieves a worker's injury apprehensions. Allow safe lubrication. If possible, the machine should be able to be lubricated without removing the safeguard. Locating oil reservoirs outside the guard, with a line leading to the lubrication point, will reduce the need for the operator or maintenance worker to enter the hazardous area. Examples of safety devices include circuit breakers, GFCI outlet, covers and two-point control buttons. Some usage. Guards and shields attached to machinery to protect the operator from moving parts, flying debris, sparks, and other potential safety hazards. They fit over blades, lathe spindles, or other machine components. Guards shall be affixed to the machine where possible and secured elsewhere if for any reason attachment to the machine is not possible. The guard shall be such that it does not offer an accident hazard in itself. Hazardous mechanical motions and actions. Identifying hazards is the first step toward protecting workers and promoting safety in the workplace. The basic types of hazardous mechanical motions and actions are: 1. Motions. Rotating. In running net points. Reciprocating. Transversing. 2. Actions. Cutting. Punching. Shearing. Bending. A rotating motion can be dangerous. Even smooth, slowly rotating shafts can grip clothing, and through mere skin contact, force an arm or hand into a dangerous position. Collars, couplings, cams, clutches, flywheels, shaft ends, spindles and horizontal or vertical shafting are examples of common hazardous rotating mechanisms. The danger increases when bolts, nicks, abrasions, and projecting keys or set screws are exposed on rotating parts. The rotating motion to be well indicated to avoid hazardous operations. Rotating parts cause hazards such as in-running net points. There are three main types of in-running net points. Parts can rotate closely to each other in opposite directions while their axes are parallel to each other. When they run closely, the stock fed between two rolls produces a net point. This danger is common on machines with intermeshing gears, rolling mills, and calendars. Rotating and tangentially moving parts also cause net points. Potential hazards include the points of contact between a power transmission belt and its pulley, a chain and its sprocket, or a rack and pinion. Net points also occur between rotating and fixed parts, spoked hand wheels on flywheels, screw conveyors, and the periphery of an abrasive wheel and create shearing, crushing or abrading actions. Types of hazards. A wide variety of mechanical motions and actions may present hazards to workers operating or working around machinery. The three basic types of hazardous mechanical motions and actions are: hazardous motions including rotating machine parts, reciprocating motions, sliding parts or up-down motions, and transverse motions, materials moving in a continuous line. Points of operation: the areas where the machine cuts, shapes, bores, or bends the stock being fed through it. Pinch points and shear points: the area where a part of the body or clothing could be caught between a moving part and a stationary object. This would include power transmission apparatuses such as flywheels, pulleys, belts, chains, couplings, spindles, cams, gears, connecting rods, and other machine components that transmit energy. Different types of cutting hazards. Point of operation, where the work is performed on the material, such as cutting, shaping, boring, or forming of stock, must be guarded. On the drawing you find some examples of pinch points and shear points. Types of safeguarding equipment. 1. Guards. Guards are barriers which prevent access to dangerous areas. There are 4 general types of guards. Fixed guards are permanent parts of a machine. These guards are preferable because they are simple and permanent. Interlocked guards automatically shut off or disengage power through a tripping mechanism when it is opened or removed. The machine cannot cycle or start until the guard is replaced. Adjustable guards are useful because they accommodate various sizes of stock. Self-adjusting guards allow the opening of these barriers to be determined by the movement of the stock. As the operator moves the stock into the danger area, the guard is pushed away, providing an opening that only is large enough for the stock. 2. Devices. Safety devices perform several functions. They may stop a machine if any part of a body is inadvertently placed in the danger area. They may restrain or withdraw an operator's hands from the danger area. They may require both hands on a control, therefore keeping both hands out of the danger area. They may also provide a synchronized barrier with the machine's operating cycle to prevent entry into the danger area. Presence sensing devices, electromechanical sensing devices, pullback devices, restraint, holdback devices, safety trip controls, two-hand controls, two-hand trip. Presence sensing devices. The presence sensing devices use a system of light or radio frequency sources and controls, which can interrupt the machine's operating cycle if the light or electric field is broken. This prevents the machine from starting up again until the field is restored, which improves safety for workers who might otherwise be exposed to risks such as moving parts or flying debris. Electromechanical sensing device. When the light beam is broken, either the RAM will not start to cycle, or, if the cycle has begun, the stopping mechanism will be activated so that the press stops before the operator's hand can enter the danger zone. Pullback devices. Pullback devices use a series of cables attached to the operator's hands, wrists, and/or arms. This type of device is primarily used on machines with stroking action. When the slide ram is up between cycles, the operator is allowed access to the point of operation. When the slide ram begins to cycle by starting its descent, a mechanical linkage automatically assures the withdrawal of the hands from the point of operation. The two-hand control devices. A two-hand control device requires constant, concurrent pressure by the operator to activate the machine. This kind of control requires a part revolution clutch, brake, and a brake monitor if used on a power press. With this type of device, the operator's hands must be at a safe location, on control buttons, and at a safe distance from the danger area while the machine completes its closing cycle. Safety trip controls. Safety trip controls are quick means for deactivating the machine in an emergency. A pressure-sensitive body bar, when depressed, will deactivate the machine. The restraint, hold-out, device. In the figure to the right uses cables or straps attached to the operator's hands at a fixed point. The cables or straps must be adjusted to let the operator's hands travel only within a predetermined safe area. No extending or retracting action is required because the hands are never allowed to extend into the danger area. Consequently, hand-feeding tools are often necessary if the operation involves placing material in a dangerous area. Though not actual guards or devices, location and distance can keep employees safe by placing a machine in an infrequently traveled area or where its dangerous moving parts are not accessible. A thorough hazard analysis of each machine and situation is essential before using this safeguarding technique. Applications of safeguards. Application to new machinery. The introduction of any new equipment provides the opportunity to improve on existing standards, to enhance safety and to maximize the productive capability of machinery. When designing or purchasing new equipment, the full requirements of this document will be observed. Application to existing machinery. The requirements of this document shall be progressively applied to existing equipment and installations. Where any safeguard recommended in this standard is not technically feasible, an alternative safeguard or documented safe system of work shall be adopted and recorded in the risk assessment. Application to modifications. Modifications, other than routine replacement and repair, and refurbishment projects provide the opportunity for improvements to existing machinery, and, subject to the constraints of technical capability, appropriate upgrades shall be implemented in accordance with these requirements. Application to installations. Machines are seldom operated alone and form part of larger installations of equipment working together. Where new machinery is planned to operate as a closely integrated line, then all machines comprising the installation shall be required to conform to these requirements. Where a single new machine is intended to operate within an existing installation, additional work will be required to upgrade the existing machinery to ensure reliable and safe operation. These requirements shall be applied to ensure that arrangements for control are consistent throughout the installation to facilitate operator training and the development of safe systems of work. In particular, emergency stop buttons must have the same effects. Labeling of controls shall be to a common standard. The choice of interlocking method and means of operation shall be consistent. How to comply with the machine's safeguarding aspect. Each organization must maintain and keep current copies of applicable local regulations concerning the installation and maintenance of machine guarding. Each organization must implement management practices and controls in accordance with the stricter of these regulations. Provision of guards. Operations must provide and maintain appropriate guarding on equipment and machinery to prevent accidental contact with machine hazards. Guards must be provided to cover machine hazards located 7 feet, 2 meters, or less above the floor or work platform. Guards must be able to withstand the force of a person falling into the guard without collapsing it into a machine hazard. For expanded metal guards, or other guards with openings, ensure that the openings do not permit contact of any body part with the mechanical hazard. Trip devices, light curtains, trip bars and wires, pressure-sensitive strips, photoelectric devices, and electrical interlocks can be used in lieu of physical controls, such as fixed guards, screens, or barriers provided that they cause the dangerous parts to stop before injury can be inflicted. A trip device should be so designed that after it has been operated accidentally the machinery cannot be set in motion unless the device has been reset manually. Guards should not create another type of workplace hazard when installed. For example, sharp edges, bump hazard, etc. Various types of guards and their application are described in the machine guarding guidelines. Emergency stops. E-stops should be provided for any equipment that must be shut down quickly in case of an emergency, and for any equipment for which the risk assessment indicated that it is needed. E-stops should have priority over all other controls in all operating situations, and should shut off the energy supplies to any drive machinery that could cause dangerous situations as fast as possible without causing any further hazards. The e-stop reset should not initiate a restart of the equipment. In addition to any e-stop provided on the main control panel, satellite e-stops should be located where there is a critical danger point. The operator routinely works near this location, and the danger point is remote from the main control panel. Examples may include multi-level equipment, long conveyor runs, or systems in multiple rooms. Hazard identification. To facilitate awareness of known machine hazards, warning labels or signs must be posted on or near the hazard. Operations with guards removed. Equipment may not be operated with guards removed or disabled, unless guard removal is specifically required for testing, observation, or positioning of equipment. In these cases, an individual must be positioned at the emergency stop button. Consideration should be given to guarding the area as necessary to prevent others from entering the area. For equipment maintenance, cleaning, inspection, etc., where guarding must be removed, the energy isolation procedures must be followed, as detailed in the hazardous energy control requirements. Inspections. The provision and maintenance of guarding must be verified at least monthly through an audit inspection process. This process can be included as part of routine inspections or audits. Training requirements. Operations must provide awareness training for maintenance and operations personnel to facilitate their understanding of machine hazards and the controls utilized by the facility to control these hazards. Retraining must be conducted when there is a change in equipment which presents new hazards or controls, or when there is evidence of deficiencies in employees' knowledge of machine hazards and controls. Compliance with machine safeguarding. To comply, the following must be in place: assessment of equipment, provision of guards, hazard identification, operations with guards removed, inspections. If this video helped you to increase your safety knowledge, kindly like, share and subscribe.